So when we're looking at deployment options for a Jamstack application and we're using containerization and we start to get into a microservices world, then Kubernetes type services like Azure Kubernetes Service are very complicated beasts to provision and set up and maintain. This is where Azure Container Apps comes in. It's a higher level abstraction over Kubernetes and provides us with a lower barrier to entry to deploy our Jamstack application using containers. So let's go and take a look and see how we can deploy our Jamstack application on Azure Container Apps. Good morning, good afternoon, or good evening, whenever it is that I find you, and welcome back or welcome along to the channel if you're new here. So today we're going to look at deploying our Jamstack application on Azure Container Apps. And for our Jamstack application, we're using Nuxt.js. If you follow the channel, then you'll know that I use Nuxt.js for my front-end deployment at least. And we've got options around the back end for the API, but we'll get to that. So let's just level the playing field and look at what Azure Container Apps offers us. So out of the box, you set up a container environment inside of Azure, which is essentially exactly as it says. It's a containing box around all of your containers. So within that container environment, you set up container applications. And within those container applications, you set up revisions. So these are immutable versions of your application. So you can have multiple revisions running at the same time, which is nice. And you can load balance across these revisions so you can see the effect of certain things that you've done in that particular revision. Within a revision is where you have your containers that make up that particular revision of your application. And as I said, you can have multiple revisions, and then you can have multiple container applications. And because this is all inside the same container environment, your container apps can talk internally across to each other. So your containers within a revision can also reach each other inside of a different revision. Each of these essentially get a URL that point you to each of these containers and revisions, but we'll get to more of that when we get to the actual deployment. You'll see how that works out. So that's overall what our environment kind of looks like. So in terms of our application, we've got our end user of our website, and what we could do is set up our container environment inside of Azure, and we can deploy a proxy container. Now we'll get to what actually this really is under the covers, but we can deploy a proxy, and then alongside that we can use Azure Storage and deploy our front end of our application at least. So once we've generated our static files, we can deploy that into Azure Storage, and Azure Storage provides us with a web server mechanism that we can use to serve that out to the internet. So because we've got that accessible to us, it means that requests that come in from our user go via our proxy server, and our proxy server forwards those requests across to the Azure Storage web server to serve out our front end to our end user. So this would be when their initial call comes in and they're downloading all of the static assets and everything like that. This is the route that they would take for that. Alongside that, we can also have a container that holds our API, and we would stand this up inside of our container environment, such that any requests that come in on /API, the proxy can interpret those and redirect those across to our API instead of going to our static web server. And because all of this is coming in via a proxy server, to the end user, it all looks like it's part of the same website. So that is just a local /API or relative /API call. So you avoid all the calls issues and all of that kind of stuff going between your front end and your back end API in doing this approach. But the problem with this is that the Azure Storage web server is publicly exposed, which means that it is exposed across the internet, so you can access it that way without going via the proxy. Now, while that's not great, it's not necessarily the end of the world, so this is still a viable option. But because that API call inside of your front end is a relative call, so it's going to /API, then that's going to redirect any of those calls back to that web server, not to your proxy server, because it's actually pointing over here if you go directly and serve your SPA from this particular web server, any API calls are also going to get redirected back here, which then isn't going to make any sense because there isn't anything listening on /API. You don't have any backend over here, so all of your API calls will fail if you directly access the front end in this way. So it's not great. People can get to your front end, but it's not necessarily functional, so it's not necessarily the end of the world. So this is certainly an option. But another alternative to that is if we take our website user, we stand up our container environment, we have our proxy again in front, which our user accesses, and then they can get the front end now inside a container app. So now this is all hosted inside of our container environment. So our front end is no longer accessible other than if you come in via that proxy server. There's no way you can get to the front end any other way. So it's nice and secure. And also we can do those API calls that get forwarded across to our backend API, which is exactly what we want. So we've now got a nice contained Spa or Jamstack application with a front end being served and an API, all behind a proxy server. So we avoid all those cause issues, the proxy server's doing all that and hiding all of that from us. So we need those 3 containers creating and deploying into the Azure Container Apps environment. So let's go and jump over and see how we can set all of this up. Okay, so here I am in my Ubuntu terminal running on Windows Subsystem for Linux. So the first thing I am going to do is make a new directory to host all this in, or to at least keep it nice and organized. So let's create a Nuxt.3 container app folder and let's cd into that, and then let's create ourselves a new Nuxt.3 front end. So let's npx nuxi front end and do our usual process here. So npm install, and then let's start up VS Code, and then what we'll do is we will add an API call just into our application just so that we can see it's working. So we'll add our forecast data, and we're going to use a .NET API. So we'll use the weather forecast demonstration example from .NET. So all we're doing is when this application view gets mounted, we make a call across to API weather forecast, and we populate that into the forecast data, which we then show in the UI. So nothing too complicated there. So we can run this up. That's now sitting there running on localhost 3000 as we would normally expect. So let's jump back over to our terminal and let's go and create the backend. So let's go up a directory level and we'll use .NET to create us a new backend. So we'll open this up in VS Code as well. And let's just go and change some of this so that we get our API. So yes, let's do that so that we can get all those added in. We'll create our summary weather, and we'll create our weather forecast endpoint, and lastly we will create our weather forecast object down here so that that's all happy. So that's our API done. What we need to do is go into our launch, and we're going to tweak this around a little bit. So I'm going to get rid of this server ready action because that opens a browser, and we don't want a browser to open every time we start our API up. And I'm going to change the arguments here so that we are listening on port 5010 instead of whatever the default is. So I think it would be 5000 for a .NET application. So we're going to change that, and we're going to change that because we don't want it to clash with the proxy server. So the proxy server is also a .NET application, and that is going to listen on the port 5000. So that's why we're changing this, so that when we run all this up locally, we don't get things fighting with each other. So with that, we should be able to come over here and run this up, and that is now up and running, and we can see it's listening on port 5010 as we asked it to. So that should be our API all up and running. So now let's come back over and let's create the proxy that we need. So let's go back up a directory again, and let's do a .NET new web -n my proxy. So exactly the same command. It's going to create us an empty web project. So we can go into the proxy, and again we can run up a VS Code instance, and we'll add all the defaults into that. And then in our Ubuntu terminal inside VS Code, we're going to add a package, and the package we're going to use for the proxy server is YARP. So YARP is yet another reverse proxy, and it's a reverse proxy that Microsoft have developed specifically for the microservice arena to make doing this kind of thing a lot easier. So it's a code-based reverse proxy. So let's go and add that package in. And now that we've got that in our CS_proj file, we can go across to the program files, and we have to go and add it in here. So the first thing we need to do is give it some configuration. So in order to do that, we can do builder.services.add reverse proxy. And there's various different ways that you can configure this, but we're going to load it from our configuration file. And all of this is coming from the documentation. So again, from our configuration file, we can specify that we get the configuration, and we get a specific section. And the section that we're going to put all of our YARP configuration in is going to be called reverse proxy. Okay, then we let our app go and build itself. Once we've built the app, we need to activate the reverse proxy, and that's done with a map reverse proxy call. So that then activates all of the routes and everything else that we've set up from our configuration. And then last but not least, we can get rid of the default URL that's listening there. So now we've got to go and over to our app settings and add in our configuration. So as we said, we're going to have a reverse proxy section in here. And the way that the reverse proxy works is it has basically front ends that are listening on specific URLs, or we can configure it to listen on specific URLs, and then it forwards those requests across to backends or clusters as it calls. And those clusters have lists of servers that it can forward those requests onto. So it kind of works as a load balancer as well, which is what a reverse proxy is. So how do we configure this? So we need a routes section for starters, and we also need the clusters section. Clusters. So they're your two main sections. So this is the section where you define what you're listening on. This is the section where you define where you're going to send those requests onto. So let's start with our cluster. And in our cluster, we're going to have a front end cluster that knows how to forward onto our Nuxt application. And we're also going to have a backend cluster that knows how to forward on to our API. So within a given cluster, and this front end back end is arbitrary. So actually what we're going to do is copy both of those, because within routes as well, we're going to define exactly the same thing. We're going to have a front end route and a back end route. So this could be called API instead of back end, but back end will do for now. So within a cluster, you have destinations, because you can obviously have more than one, and then you can list out your destinations. So destination 1, and again that's an arbitrary name, and your destination has an address, and the address for our front end is HTTP localhost on port 3000. Which is where our Nuxt application is listening on. Let's just correct that spelling. So what we can do is copy all of that destinations block, into our backend, and our backend destination is going to be localhost on port 5010. If you remember, that's where our API is running. So then what we need to do is set up the front ends essentially to listen on the right thing. So what we need to do is, in a given route that we have, we first have to tell it the cluster ID that it should use. So that's just our arbitrary named front end. So again, we can do the same with backend, change that to backend. And then what we need to do is tell it which routes to listen on, basically. So how is it going to isolate that this is a front end request? So for that, we have a match section. And within that match, we are going to match on path. And the path that we're going to look for is a catch-all path. So basically anything that is coming in to our reverse proxy is by default going to forward across to our front end. Okay, so we're going to have another match on our back end as well, but this isn't going to be a catch-all, kind of. What we're going to do is prefix that with /API. So anything that comes in on /API and then anything after it is going to forward across to our back end. So for instance, when our front end makes its call to /API/weather forecast, the proxy is going to pick that up and forward that across to our back end, which is configured to call our API down here. Now the trouble in paradise is that our API is, if we just jump back over to our API is listening on just /weather forecast, not /API weather forecast. So we need to tell the proxy basically to remove the /API. You could put /API in here, but then you're kind of giving the backend knowledge about the routes, which you don't really want to do, because you might want this API listening on another application where it's not /API, it's /backend, for instance. So it's best to keep your API as vanilla as you can in terms of its URLs and as ignorant as possible to how it's actually being called. So what we can do to overcome this is we can add in a transforms section to our backend, and that is an array. And within that array, we specify that we want to path remove prefix, and the prefix we want to remove is /API. With all of that in place, I can now run up this proxy server with .NET Run, and I'm changing the URLs property so that it listens on localhost 5000. So that is up and running. So I can open up a browser on localhost 5000, and it's serving up my Nuxt application. And then I also see the weather API being called as I would expect. So that is correctly calling now to my front end to load up my SPA application, and then also correctly calling across to my API, but using localhost 5000. So we're avoiding all calls kind of problems in doing that. So that's all running locally. So that's a good start. So now we'll move on to putting these components or parts of the application into containers. So let's concentrate on the front end. And I've done some videos on this before, and I'll put a link to putting Nuxt into a container above. But essentially what we need to do is we need a Docker ignore file. So let's jump over to Visual Studio Code, and in here we need a Docker ignore. I'm just going to paste some stuff in there. If you want to see this in more detail, then you can go to the video to have a look at that. We also need a Docker file. So let's copy that in and let's save that. And the important point here is that we're going to expose port 3000. So Nuxt is going to run on port 3000, and we're going to expose that out on port 3000. So with that done, we can jump back over to our terminal where we're in our front end directory, and we can do a Docker build and tag it as Nuxt3 front end. and the current directory as the context. So we'll let that build and put itself into a container. So that's built and given us our Nuxt.3 front-end container. So now we need to push it up to our container registry. So I'm just going to log into GitLab, and I'm going to re-tag that container as a GitLab container in my container registry and push that up. Well, that's done. So now let's have a look at doing our backend API. So I'm going to do this in a slightly different way because it's a .NET API, but you could equally do it with a Docker file, which I've shown again in a previous video where I've packaged Nuxt into an ASP.NET container. But what I'm going to use is a new project type that Microsoft are working on, which allows you to build containers without needing a Docker file. And to do this, we need to add a package called microsoft.net.build.containers. So I'm going to add that to our backend project. And then inside the CS proj is you can basically just add some extra configuration in there that tells this extra library that we've added how to build the container. So I'm going to give it a container image tag of latest. I'm going to give it a container image name of Nuxt.3 API. And it's going to use a default container publish profile. So I can save that and then jump back over to my terminal. I can do a .NET publish saying that the operating system that I'm publishing for is Linux and it's x64 and I want a release build. So here we can see that it's telling us it's building a Nuxt.3 API with a latest tag on that particular image. So it tells you what it's building. And so that is now built, much like we did with our front end. We need to push this one up to our container registry. So again, let's log in, make sure we're logged in, and let's re-tag this one for our container registry and push this up. While that's doing that, I'm going to jump over and do the same thing inside of the Proxy front end. So I'm going to add the package and add in the extra settings into the CS proj file. So again, latest Nuxt.3 proxy server this time for the container. And then let's jump back over and build that. And then let's push that up to our container registry. So that's all our containers built and pushed up to our registry, but let's just give it a quick test running inside of the containers locally. What we can do is in the front end, we can do a Docker run and we port forward port 3000 from our local hosts into port 3000 inside the Nuxt front end container. So let's run that one up. We'll do the same idea for the Nuxt API, except this time we're going to port forward on port 5010, which we were using earlier, to port 80 inside the container, because that's by default what .NET exposes. So we can see that that's up and running. And likewise, we'll do the same for the proxy server. We'll do a Docker run and we'll port forward port 5000 on this one to port 80 inside the container. But here we need to specify a couple of extra properties, and we use the environment variable argument, and what we're doing here is we are overriding what's inside of our app settings with an environment variable. So .NET by default cascades up from app settings, and if there is an environment variable that corresponds to that particular setting, it will use the environment variable in preference. So if I just jump over to the app settings, it's essentially working its way down from the root of our settings. So we've got reverse proxy, and then you use an underscore underscore for every time you go down the hierarchy. So we want reverse proxy underscore underscore clusters underscore underscore front end underscore underscore destinations underscore underscore destination one underscore underscore address. And so if we now come back over, you'll see exactly that that's what that is. And we replace that value with what we need to have that set to work with our containers, and we want that to be our IP address of our machine that we're on port 3000. So we have to do that so that that retargets the proxy server to point to our front end. We also have to do that, the same idea for the back end, so on port 5010. So let's run that up. And now if I bring up a browser and go to localhost 5000, we can see that my Nuxt app is running and I've made my API call. So let's just bring up the network and refresh that so that we can see everything going on. And inside there, I can see a call to API weather forecast. So that's it all running up in containers, which is good. So now let's move on to the meat and potatoes of this and get all of this running up in Azure Container Apps. So here I am in the Azure portal, and let's go and create our container app. So if we look for container apps or something like that, you should see this icon pop up under services, so container apps. And as it shows, I've got no container apps at the moment, or no container environment even, so I'm starting from complete scratch. So within this subscription, I'm going to create a new resource group for this, and we have to create an app name, so give that Nuxt 3 front end. We'll deploy the front end container first. I don't want that, I want UK South. And we'll create a new container apps environment, give it a name. Then we can go over to here, and I don't want hello world. So my container is the Nuxt 3 front end. I want a private repository, and that is going to be my GitLab repository. And if you want to know why I'm using GitLab, I've got a previous video on that tells you why I'm using GitLab. I've done a comparison of container registries, so you can go and check that out if you want to. So my username, my password, and finally the image name and tag that we're going to deploy. So that's going to be Nuxt 3 front end latest. It's Linux. That allocates some memory to this particular container, so that's fine. Now we are going to enable ingress, but we're going to limit the ingress on this to the container apps environment, so it's not publicly exposed to the internet, which is this one. And we're not going to set up our own VNet, although you can do that if you want to, but of course then you're incurring additional cost for the VNet. So we're going to enable HTTP ingress, but limited to this because it's only our proxy server that's going to forward traffic to our Nuxt 3 front end. Transport is auto, we can do that. We can set the target port as port 3000, which if you remember is the port that's opened on our container, and that's all validated. So we'll let this go and create our resource group, container apps, and that Nuxt 3 front end container app inside of our container app environment. And we'll come back. That's going to take quite a while, so go and get a coffee and we'll come back when that's done. Okay, so that's complete. So let's jump into that resource group, and then we can jump over to our container apps environment, and inside of our apps we can see we've got our Nuxt 3 front end, which is as we would expect. So now we need to create one for our backend and one for our proxy. So let's create, and inside of there let's create Nuxt 3 API or backend or whatever, and that's all good. And again, I don't want the simple start, I want my private repository. So we have to go and enter all this aggravation again, unfortunately. So this time it's Nuxt API and the latest image. And again, we're going to enable ingress on this one, but limit it to the container apps environment, same as we did before. And this time we're going to port forward port 80. So let's kick that one off. And then we can just come back over to our container apps environment. And let's create another container app and call it Nuxt 3 Proxy. And we don't want the quick start image again. And this time we do Nuxt 3 Proxy. And when we get to ingress this time, we do want to accept traffic from anywhere. And again, we've port forward that to port 80 inside the container. So that's the only difference now, is this one is accepting traffic from anywhere. So we can review and create and kick that one off. So we've got our front end, our proxy and our API. So now let's just go into the proxy, because we need to go and change those destinations if you remember where the proxy server is pointing, so that it forwards across to both the API and the front end accordingly. So to do this, we go to our Nuxt 3 proxy, we go to the containers blade, we go to edit and deploy, because we need to change the configuration. Click on our container image, which brings up this dialog, and down at the bottom is environment variables here. So we can enter our environment variables here. So if you remember the name of our environment variable for our front end, it's hard to see here, but it's reverse proxy __ clusters. So exactly what we configured when we were running locally, front end destinations, destination1 address. Okay, and we'll do a manual entry. Now the variable that we need, or what we need to set this to, let's just open another tab over here, is the front end, and in the overview we need the application URL. So as you can see, it's got this internal inside of it, which means that it's not exposed externally. So we can copy that, come back over here, paste that in there. So we get https nuxt3 frontend.internal and then a random container name inside of our container apps environment. So we need to do the same now for the backend as well. So let's create reverse proxy clusters backend this time, destinations, destination1 address, and do the same. Come over here, go to the API, copy that one, which again, as you can see, is internal. Paste that in there and save that. And this is now going to create a new revision with that configuration inside of it. So we can effectively ditch our old revision. So if we go on revision management, here's where you can manage how you apportion your traffic across your various revisions. So that's deployed our revision. So now if I come to the Nuxt3 proxy, and you'll see there's no .internal on that one. So if we navigate across to that, we can see that my Nuxt application is up and running, and my API has been called correctly, and I'm seeing the weather forecast. So exactly as we saw locally, if I just bring up the F12 tools and refresh that again, we see all of our Nuxt stuff being called and our weather forecast being called on API weather forecast. So again, it's using the domain, so it's relative to that, and it's just calling /API/weather forecast. So it gets around all the calls issues and all of that we get with our API. So that's our Nuxt application up and running with an API on Azure Container Apps. And the benefit now, of course, is that if you've got different teams that work on your API as opposed to working on your Nuxt application, you can now split this work across those teams, and they can work happily in the ecosystem that they're happy working in. So .NET for the API and Node for the front end, and they can carry on working happily together, and you just deploy it up into your container app. And of course it scales as well. So as your API gets more and more demand placed on it, but your Nuxt application doesn't get your demand placed on it because it's only effectively downloaded once to the browser. So if that doesn't change very often, your API may need to scale differently to your front end, which again is another benefit of the container apps, is that you can scale your back end, your API, differently to your front end Nuxt application. So that's all I wanted to cover in this particular video. So again, I need to thank my sponsors for keeping the channel going, and by all means let me know what else you want to see from the channel. So let me know in the comments what you think, whether you're finding this useful or not, and with that I will see you in the next video. Thanks for watching.